In this video, we're going to be looking at wave interference. Let's model some wave interference of water before we look at wave interference in light. So let's check this out. When notice that those drops of water, once they hit the water itself, they make these concentric circles of crests that go away from the source, which would be right there. So think of that model when we start to do our wave pictures, if you will. So now that we know what we're trying to draw with one wave, let's see what happens when we put two waves together. So these are two wave fronts that are modeling where a drop would go if this was water, approximately right there and right there. So it asks us to sketch where the crest would be a short time later. So a little bit later, it would move like that. Okay, so moving away from their sources. If we were to continue to look at the waves and where their crests are specifically, the picture would start to look like this. So where the lines cross, that's a crest and a crest, and we know that would be constructive interference at A. Here at B, between crests, that's trough to trough, so that's also constructive interference. C is location where we've got crest and trough, so we would expect destructive interference there. Okay, now we need to explain why trough to trough is constructive interference. So if we had a trough heading towards another trough, it would, you add the value of the amplitude, and so a double trough would be constructive interference. Okay, now my graphic here got a little distorted, and it's actually kind of good because that way we can see what it looks like in a non-perfect situation, if you will. So it asks us to draw these lines in that connect the crests, and these are going to be really important for us because in these situations we get just constructive interference along these lines. So we'll call this first line right here the 0th line. Then on the other side there's a first line of constructive interference, a second line on either side of constructive interference, and a third line of constructive interference. We're going to skip the minimum lines. Those would be the lines of destructive interference. So feel free to draw those on your own if you'd like. Okay, so let's compare what happens when we move the two sources closer to each other. So here if you want to call that where the drops of water were going, so right there, source 1 and source 2, they're a certain distance away from each other, and we get this or these lines as our lines of constructive interference. If we move the sources closer to each other and still have the same wavelengths, notice what happens to the lines. They become much further apart. Okay, now let's say we keep the distance between the sources the same, but increase the wavelengths. And in this situation, we also have a situation where the lines are much further apart. And that's it.